chemistry students, now we're going to talk about writing ionic compounds and ionic nomenclature with transition metals because they are a bit different than regular metals. Okay, first thing, you need to remember that transition metals can have different numbers of valence electrons. They change, so they have different charges when they become ions, and we have to indicate the charge that the metal takes with a Roman numeral in the name. Second, after that, you crisscross the charges to make the subscripts, and then you make sure they're at their lowest whole number ratio. Okay, now let's have an example. Iron 3 oxide. So iron is right here. It has the chemical symbol Fe, so we're going to write Fe right here, and it says that it is 3. This 3 indicates its charge, or its oxidation number. And we know that oxide is actually oxygen right here. It's in group 16, which means it has 6 valence shell electrons. It's easier to gain 2 than lose 6. Gain 2, that's its oxidation number. Okay, so now that we have our ions, we're going to crisscross. So I'm going to write the iron 3 over here and the O, oxygen, over there. Now crisscross. That 2 now goes down by the iron, so it's going to be Fe2, and that 3 goes down by the oxygen, which is O3. So our final formula is Fe2O3 because they are in their lowest whole number ratios. They do not have a common denominator. Fe2O3, that's our final formula. Next example, tin 4 chloride. Tin is right here. It has the chemical symbol Sn. It is not a transition metal, but they change their oxidation numbers depending on what they're bonded with, just like the transition metals do. Okay, so Sn, and it has an oxidation number of 4. All metals are always positive, so I'm going to put a +4. Chloride is the same thing as chlorine after it's become an ion. So chlorine is Cl. It is in group 17, which means it has 7 valence shell electrons. It's much easier to gain 1 than lose 7. That's its oxidation number, gaining 1. Now remember, it's negative. If you gain an electron, it's always negative because electrons are negative, you're gaining negativity. Now we're going to crisscross. So we have Sn, our metal always comes first in our formula, and then Cl minus. That 1 goes down by the 10, and we never put 1s, and this 4 goes down by the Cl. This is in our lowest whole number ratio. We cannot get these numbers any smaller, so it's SnCl4 is our final formula for tin 4 chloride. Next one, we have lead 4 oxide. So now let's look. Lead is right here. Its chemical symbol is Pb, so we're going to put Pb over here. Our cation is going to be lead. It has an oxidation number of 4. Metals are always positive because they lose electrons, so I'm going to put Pb +4. Oxide is oxygen. Oxygen is in group 16, which means it has 6 valence shell electrons. It is easier to gain 2 than lose 6. So gaining 2, that's our oxidation number, or our charge. Now we're going to crisscross. So I'm going to write Pb +4 O -2. This 2 goes down by the lead, so it's Pb2. And this 4 goes down by the oxygen, so it's O4. All right, now this is where it matters as far as simplifying and doing the lowest common denominator. So 2 and 4, their common denominator is 2, so we are going to divide each by 2. 2 divided by 2 is 1. So I'm going to do Pb, and we never put 1s. 4 divided by 2 is 2, so I'm going to put O and then 2. So our chemical formula for lead 4 oxide is PbO2. Last example here is 10,2-sulfide. 10 is right here, it's SN. This 10 has an oxidation number of 2. Metals always lose electrons, so it's going to become positive. So the oxidation number is +2. Sulfide, if you remember in naming, sulfide is actually sulfur. Sulfur is in group 16 and has 6 valence shell electrons. It is much easier to gain 2 than lose 6. So that's its oxidation number, gaining 2. When you gain 2 electrons, the charge becomes a -2. Now we're going to crisscross. So we have SN, which is 10, with a +2 oxidation number. S with a -2 oxidation number. The 2 over here is going to come down by the 10, so it's going to be SN2. And this 2 is going to come down by the sulfur, which is S2. Now we have these two numbers, 2 and 2. They both have a common denominator of 2. So we are going to simplify it in the whole number ratio. 2 divided by 2 is 1, but we never put 1s. And then 2 divided by 2 over here is 1, and we never put 1s. So the chemical formula for 10,2-sulfide is SNS. Now let's talk about writing the names. So when we write the name of a transition ionic compound, you must always put the Roman numeral to indicate the charge of the metal. Then you have to uncrisscross to find the charge of the metal, and then the charge of the nonmetal is always constant. So let's go through an example. We've got PbCl2. First we're going to find the nonmetal ion with the charge. Here is our nonmetal, is Cl, okay? And Cl is right here. It's in group 17, so it has 7 valence shell electrons. It's easier to gain 1 than lose 7. So that's what its oxidation number is, -1. Now, the charge of our metal. We're going to uncrisscross, so that 2 is going to go up. So we have Pb +2. Okay? And over here, that number would have gone up also. That's a 1. And this is a -1, so we're good there. The name of our compound, remember we do our metal first. Pb is lead. Then we do our oxidation numbers in parentheses in Roman numerals. Our oxidation number is 2, so it's going to be lead 2 chloride. So we change our chlorine, we change the ending on chlorine to ide, IDE, so it's chloride. Cu2S. We're going to find our nonmetal ion with charge first. Our nonmetal is this S, which is sulfur. It is in group 16, so it has a -2 charge because it's easier to gain 2 electrons, that's its oxidation number, than lose 6. Now we're going to find the charge of our metal. This 2 right here goes up. Let's uncrisscross, and that's good because it's 2. And then this 1 is going to go up by the copper. So we have Cu +1. Since this number matches this number down here, then we know this number is correct. So we always name our metal first. This is copper. And it has an oxidation number of 1. So we put the Roman numeral 1 right there. This is sulfur. We change our ending to IDE. So we're going to change the UR to IDE. So it's copper 1 sulfide. Next example, we have SNO. So our nonmetal ion with the charge. O is oxygen. It has 6 valence shell electrons, so it's easier to gain 2 electrons. Gaining 2, that's its oxidation number. We have a -2. You gain electrons, you gain negativity. SN. So we need to find the charge on our metal now. SN. If we do our reverse crisscross, there's a 1 here and it goes up, and that'll be a 1. And then we have a 1 here and that goes up and it'll be a 1. But if you notice, the oxidation number on our oxygen is not 1, it's 2. So we have to multiply this number by a number to get 2. And in order to do that, we multiply it by 2. If we do that, we have to multiply this number by 2, which means our oxidation number is +2. So the name, we always name our metals first. SN is tin. Then we need to do our Roman numerals for the oxidation number. The oxidation number is 2, so I'm going to put a Roman numeral 2. And then name our non-metal is oxygen, but we change the ending, and then we add it to we add IDE to it. So it's tin to oxide. Okay, last example here. Non-metal ion with charge. Here's our non-metal. It's F. F is fluorine. It is in group 17. It has 7 valence shell electrons. It is easier to gain 1 than lose 7. Gaining 1, that's its oxidation number. Now let's find the charge of our metal. So we're going to reverse crisscross. That 3 is going to go up by the cobalt, and that 1 is going to go by the fluorine. Our oxidation number here is 1, so that's good. So that means this one's going to be 3. So cobalt is going to have a +3. Remember, our metals always, always, always lose electrons. So cobalt, and then we write our Roman numerals as our oxidation number. So our oxidation number is 3, so we're going to write Roman numeral 3. And then fluorine, and we change our ending to IDE. So it's not fluorine, it's fluoride.